Good afternoon, everyone. To whom is here face-to-face in this conference room, and to whom is connected online. I'm Carlo Bruno from Pollution Analytical Equipment, an Italian manufacturer of analytical analyzer. It's my pleasure to talk today about the importance of real-time air monitoring as a way to reduce cost, improving the efficiency of preventive maintenance and process control in the refinery sector. The control of environmental impact of petrochemical process is important, and monitoring the air concentration of harmful compound is a key point in order to reduce cost and minimize the environmental footprint. Also, the European Union published a specific directive for air quality and industrial emission, where EU sets emission limit value and specify the parameters to control. Within this such framework, also the best available technique reference document called BREF has been released. The BREF concern some specific activities of industries and specify also the best available technology to measure the emission into the ambient air. But what does we mean for emission? Emission can be classified as stationary source emission or diffusive and fugitive emission. In this session, we will talk about only diffusive and fugitive emission because these are the main emission correlated to the refinery sector. Also, the diffusive emission are also correlated to the odor nuisance. The first step to understand is where those diffusive emissions are generated. Generally, in every places where oil and related products are handled, stored, transported, may lead to diffusive emission. Example of diffusive emission production can be observed in flanges, valve, pumps, and this represents almost from 20 to 50% of the total refinery VOC emission. But there are also other places where diffusive emission can occur. For instance, in the wastewater treatment plant, in the bitumen plant, or in the loading and unloading terminals, but also in the tank yard, because of the tank breathing due to the evaporation losses. But how currently are measured those emissions? There are several best available technology, also described in the BREF. For instance, starting from conventional VOC sniffing. In this case, is used a simple PID or FID detector to sniff leakage. Or there are more complicated systems such as LIDAR or sodal occultation flux or optical gas imaging techniques. Finally, there is also on-field sampling, where the sample is collected into a sorbent tube, and then the sample is transferred in the lab and then analyzed using a gas chromatograph. Later, we will see how we can use in a better way a gas chromatograph. So, appear to be very important to have an integrated and efficient approach in order to measure diffusive emission. This can be done using all the complementary analytical techniques, but it is also important to measure in real time, and also tracing some specific VOC as a marker is very important, because you can have a better indication of the diffusive emission. So, using this integrated and real-time approach, we can predict alarm, avoid false alarm, and know exactly where the source is and what is the cause of the issue. So, if we have a network of gas analyzer that covers the whole area of the refinery, can be a solution. In this case, gas chromatography, because of its capability to identify specific marker, can also help us in this purpose. Therefore, our solution is a network of gas chromatograph. Our solution with a network of gas chromatograph that can be easily installed with a low cost of maintenance will help us a lot. Because, again, gas chromatography is a specific technique able to identify specific marker. Then it can be a good candidate to be included in the best available technology. So it is possible to have a new GC system with a miniaturized footprint to have a great portability with lower cost and great performance. We realized in collaboration with university and Italian Research Center, we realized a new palm-size portable GC system with great selectivity, sensitivity, and it can be measured continuously, and it can be installed everywhere in every kind of situation. The analytical core is placed inside this small and waterproof cabinet. Inside the cabinet, there is also a UPS battery that keeps the system alive up to 6 hours. There is also the connectivity pack with LAN, Wi-Fi, 4G, and data can be transferred to the cloud or by Modbus protocol. For better reliability, we also install a span gas cylinder for the auto check and auto drift compensation. So Pyxis GC, our Pyxis GC, help us to simplify the analysis on field. Instead of doing the analysis in the old school way, we bring the lab directly on site. This simplifies our job, and this new technology allows real-time monitoring, save time, and avoid any possibility for error, because we analyze the sample directly on field. So in this case study, in this picture, you see the installation of the Pyxis GC in a refinery because the customer wanted to measure the diffusive emission in a specific area of the refinery. This chromatogram is a typical pattern in case of normal situation. You see just a few ppb of aromatics. Suddenly, after a specific event, we recorded an increased amount of aromatics, in this case BTEX. In particular, you see a big amount of benzene, and in this case, the ratio between benzene toluene also helped us to find the source of the issue. After a remediation procedure, the chromatogram and then the emission return in a normal condition. This kind of behavior can be observed not only in case of anomalous event, but can be observed also as a temporary event in case, for instance, of loading and unloading of oil. Usually, diffusive emission in a refinery sector can be correlated to the characteristic odor nuisance due to the presence of some specific compounds, such as sulfur, nitrogen, volatile hydrocarbons such as aromatics, and in particular BTEX, as we've seen before. But in this case, gas chromatography can help us because in addition of its capability to identify specific marker, chromatography can be used also to take a picture of the current situation, creating a fingerprint odor that can be correlated to a specific process of the production. For instance, in this case study, we are in the bitumen plant. So, analyzing a bitumen conglomerate with gas chromatograph, we obtained this kind of pattern on the left. Later, analyzing the ambient air in the area where tracks are loaded with bitumen, we recorded the second chromatogram. If we overlap, we can see a perfect match overlapping of both chromatogram. It means that the odor nuisance in the area where we analyze the ambient air can be correlated to the chromatogram of the bitumen sample analyzed before. So it is a kind of nose that can identify the source and the type of the odor. In conclusion, what we have seen today is a new MEMS GC that will open up wide possibility and improve the environmental and process control. With Pixis GC, it is possible to create a network of analyzers. And having a precise picture of the air quality around all the areas of the refinery will reduce costs involved in environmental control, preventive maintenance, and the impact of neighboring population. Thank you very much for your attention, and I would also thank you, my colleague Davide, for his technical support, and thank you very much also to my friend Eugenio that is not here with us.